Okay. Hi, good evening, everyone. My name is Chetan Singh Chauhan. I'm Secretary of Kaziranga House, and I welcome all of you to this end-term revision session marathon that we have organized for all of you to help better prepare for your end-term examinations. So it will be a series of end-term revision sessions for different courses. The first of which is this CT end-term revision session. I welcome you all to this session. Sagan, are you here? Uh,
Hello, Chetan. Yeah,
Yeah,
I'm here.
right. Yeah, okay, perfect. So, guys, we have today with us the current computational thinking TA, Sagandeep Kaur. Please welcome her. And Sagan, you may take over now. And, guys, one small request to all of you, please make the session a little more interactive. I don't want Sagan to just keep speaking and speaking to a silent crowd. Just interact with her, ask questions if you have any. If you don't have any questions, you can say that as well, that I don't have any questions. If you have not studied properly, you can mention that. At least she will have an idea of what sort of a crowd she's dealing with, so that she can better explain everything to you, all of you. So keep that in mind, make the session a little more interactive, give active feedback to her, so that she can better manage the session. So that's a small request from my end. And Sagan, you may take over now, please.
So, hello, everyone. I hope I am audible.
Yeah, perfectly audible.
Okay. Okay. So, we will start the session. So, today we do from week 9 to 12 ET revision. Okay. If any of you have any doubt, please let me know during the session. So, we will start from the very basic.
Just a small, just a second, second.
Yeah.
For those of you who are wondering why are we not starting from week 1 to 9, we had a previous session for week 1 to 9 that was also conducted by the current computational thinking TA, Subhradeep Bhaumik. So it was a wonderful session. It was a one-shot video from week 1 to 9, and he even managed to squeeze in a PYQ. So Sagan decided that she will take over from where Shubhadeep left. So I don't think you will need anything else other than these two videos. So attend the session and watch the previous video if you are not done with your week 1 to 8. Yeah, sorry to cut you off, Sagar. Please take over.
Okay. Yeah. So, we were starting with the collections. So, in previous weeks, we have already seen lists and dictionaries. Now, we were introduced to matrix also. Matrix is nothing new. It is just a list of lists. Okay. So, when we look at the matrix, this is how we represent it. Any value, suppose 1, comma 2, then another list, 2, comma 3, and this will again be included in a list. So, isn't it like the list of lists? That is what matrix is. So, to find any item in the list, what we will do is, suppose we wanted to find uh, to the element here. This is 3. So, how do we find it? Suppose this is a matrix M, so we will write M 2, comma 2. 2 represents row and column. So second row and second column, which is the value, which is 3. This is so very basic. Now let's see how do we create a matrix. Matrix are two-dimensional tables, just as I have shown you, and we can also get random access to any element. Also, we got random access to any elements in dictionaries also. Do remember these two things. So how do we create a matrix? Creating a matrix with n number of suppose 2, comma 2 rows, 2 rows and 2 columns, which is 2 by 2 matrix. First, we will initialize a matrix like this. Either we can do the matrix in a dictionary format like this, or we can do in a nested list also. Both of these works. Okay, we can do both of these, either in dictionary or in list of lists. Yeah, so this is the initialization step. Then we have initialized I to 0. Again, this while loop, while I is less than rows. So there are two while loops, this one and this one. First is for rows and other is for columns. Of course, we need to iterate like this also and this also. So first what we will do, 1, 0, 1. This is because rows we took 2 and columns we took 2. So I value will be 1 and 0 and 1. So matrix of 0 we will put as empty dictionary. And j is also 0. First j is also 0. Then j equals to 0. And matrix of ij will be equal to 0. So how we will put it? First there was this initialization, matrix initialization. Then again we are initializing matrix of I with this empty dictionary. Then what we are doing is we are putting a value inside it. This. So at 0, 0, at matrix of 0, 0, we will have a 0 value. So this is what we are doing. This is matrix of 0, 0. The value at matrix 0, 0. This is the value. Okay. Now what we will do, we will change our j. Why j? Because it is in the inner loop. So we will change this 0 to 1. So what we will do here is, again we will put 0 here. Okay, like this. Now what will be the next step? So at 0, 0, 0, 1 also we have put 0. Now I will change. I will change to 1. So here again we will create this empty dictionary like this, and here also we will put 0 and 0. Okay, so how we will represent it is in like 0, 0, 0, 0. This is this is a dictionary, and this is the dictionary of dictionaries. This is how we created the matrix. I hope this is clear. Then how do we process through a matrix? For each C in columns of a matrix and for R in rows of matrix. See, here also what we were doing is, while I is less than row, and then we go down while j is less than rows. So we were having two loops to make the matrix. So to process the matrix also, we will have two loops. First, what we will do for C in columns of rows, 0 and 1 we will take, and R 0 with 0, C equals to 0. What will be the R values? 0 and 1. Okay, so we will iterate this and this. Then column will change, column will become 1, and again for 1 we will take this 0, which is R equals to 0 and R equals to 1, like this. Okay, this is how, and we can access any element like this, just I have told you before also. And then we came to next topic, which is of graphs. From the matrix itself, we can make graphs. How? So if two elements, suppose our graph is this 1, 0, 1, 0, 0. This was our matrix. Suppose this meant that there is an edge here.
Excuse me.
Okay. Yeah.
And do we need to remember this pseudocode?
Do I need to?
Remember this pseudocode?
You don't need to remember any pseudocode. You just need to understand what these pseudocodes are doing. Okay, so in exam, pseudocode will be given to you, and you will have to see that how what are the workings. So you just need to understand. You don't need to remember any pseudocode.
I'm actually, especially in the week 9 to 12 thing is the concepts I'm understanding, but question I've solved, but still, while going through the pseudocode, I'm having problem like predicting the outcome or something.
Yeah, so don't try to memorize it. Just try to understand what they are doing. So these two things which are very basic, like how do we iterate through it, iterate through matrix, j- just like we iterated through dictionary also. These kind of things you need to know, how to iterate through dictionary and matrix, and how to create a matrix. These are very simple. Okay, so if you know the basics, how we are iterating and what how we are changing the values. You can understand the codes also. So codes you will only understand when you practice. Have you done GS and PH practice assignment and grade assignment? There are
Yes.
many pseudocodes there now, so they will definitely help.
And the creation of the matrix could be again explained just briefly. The creation part.
Creation. Okay, so what we were doing here is we were taking rows, row equals to 0. The number of rows is 0 currently. Then number of columns we will take as 0 and 1. So at this point, this was our dictionary. Okay. Then we changed our rows, which was the outer loop, this loop, to 1. Okay. When we change it to 1, again our column will become 0 and 1. And then what will, where we will be? Here. Okay. So first we made this empty dictionary, the outer dictionary. Then inside it, we made one more dictionary. When R was 0, at the point R was 0, we made this empty dictionary. And then when we change the this value of column, we put the value of 0 and 0 at
Y-
here.
Yeah, Jivraj, you have any doubt?
Yeah, so I was just wondering, we keep on writing these codes on paper. So just wondering if there is some compiler or interpreter where we can execute this code question to 7.
Actually, these are the pseudocodes. So you won't be able to compile these codes.
Oh, okay. So these are meant to be on paper, is it?
Yeah, they are there to make you understand how do we go through the codes. Like in next term, you will have Python. So there you can understand when you will go through the code. Here you are just understanding the code, like what are the steps and how we are going through it. We are just learning to understand how a programmer is thinking. How do we create codes? Okay. Here you don't have to write any codes. That is why they are called pseudocodes, not
Uh,
codes.
can I add something to that again?
Yeah, please.
Yeah, Jivraj, so computational thinking is actually a foundation course for programming. So it helps you build that logic. So when you take up the Python course next time, right, you will have your OPP exam there. You will be able to do that OPP exam in maybe less than 45 minutes if you do the computational thinking course properly. Okay, so please focus here. You will be able to do your OPP in less than 45 minutes.
Okay, I thought it was for 2 hours.
But you will be able to do it. I wasn't able to do it, but you will be able to do it. Yes, again, you can carry on.
Okay. So the person
Ma'am,
who was asking this, how do we create the matrix? Is it clear now? Hello.
Yes, ma'am.
Okay. Yeah, someone was saying something.
ma'am, in this code, you have taken index number 1 and index number 2, right?
Okay.
But in
No,
Python,
no, I took 0 and 1. Na? We are starting from 0. I took 0 and 1. That is why I is less than 2, not equal to. Okay.
okay, ma'am. Okay.
Even if we take indexing from 1, it shouldn't be a problem. Only if we took I equals to 1 and then from j also 1. So we just need to put here equal to. Then also we will get the same here also equal to. Okay. That will also work. 1 and 2.
Okay, ma'am.
Okay. So we were on graphs. I was telling that when do we have an edge? When there is this matrix 0, 1, 0, 0. So which means there is an edge here. Okay. So there was this pseudocode example of this code given. Create a mentor graph which will take marks as an input. Just try to go, we will just try to go line by line. Okay. We will take the length of keys of marks as n because we are creating a matrix of n cross n. Create a matrix will just create a matrix of all the zero values. Okay. This was just told in the lecture by default. So for I in keys of marks and for j in key, again, what we are doing here is iterating, right? Just like here. This also, there also. Okay. So we are iterating to the keys of marks and again the keys of, so that was just the sequence number 0, 1, 2. So these were the sequence numbers. If we will take the marks difference, so it was like this: 0 got marks. How many marks? Whatever marks he got, 90. Then one person got. This is dictionary. I hope you all know this. Okay, and 2 got, so on. Okay, so what we are doing is we are subtracting its value and we are getting the marks difference between ith and jth student. Why student? Because it is just the sequence number. So if their marks difference is between 10 and 20, we will create an edge. This line. This is just the line how we access our element. So I told you matrix 2. I told you this one. We will be, this is our matrix. So we will access this element using this. This is the row and this is the column. So this is how we are putting. So how do we make an edge? When if the difference between their marks is between 10 and 20, then we will make an edge from I to J. Okay. So suppose we got 0 and 1. Again, here we got 0 and 1. I also 0 and 1 and J also 0 and 1. So first I will be 0 and we will compare with 0, 1. These are the J value and these are the I value. If the difference between marks is this, then we will go down. Okay. Then we will go inside this block. You have to keep in mind the indentation also. Okay. This is a block. This line will only be executed if this condition is satisfied. So if there is this, so we will make an edge. If there is none, then it will remain the same, 0, 0, the matrix. Okay. Then suppose now with I is 0 and with J as 0, we did not get any, the difference is 10. Difference between their marks is between 10 and 20. So we will, so 0 will remain here. Then when J will change, J will become 1. So this 0 will also remain there because the difference was not there. We are just assuming it. Okay. We are assuming that the difference between the first and the second is, suppose first and second, not first and second. Let's put 0 and 1. That will be better. 0 and 1 is not between 10 and 20. So we won't go there and we will, for this, what will be the I value and J value? Tell me this first. Anyone? See, for this, I was 1 and J was changing. J was changing to 0 and 1. Okay. Now this is completed. This is done. Now we go down. To go down, we will change our ith value. So I will become 1.
I will be 1.
2 and 0.
Yeah, right.
1 and 0.
1 and 0. Correct. 1 and 0. So again, then ij will change to 1 and 1 here, and 0 will remain here as it is. So I hope this code is clear. If there is an edge, it means if there is an edge, it means that the value between I and j, the value of matrix ij is 1. If there is an edge in the graph, we can go from graph to edge and graph to edge, edge to graph. We can go from matrix to graph and graph to matrix. by using this. Okay, is this clear? So in week 9 also, this kind of codes were there only. Okay, we were creating a mentor graph, then we were checking some conditions. So in week 9, basically you need to know how to iterate through metrics and how to create the metrics. So I hope this is clear now. Is it clear?
Yes.
Shall we?
Yes.
Okay. I will give you one question to solve. Okay, try solving this question. Okay, if any one of you have doubt, please let me. I hope you are all are solving the question.
Ma'am, option 4.
That is correct. Anyone had doubt in the question?
No, ma'am.
Okay. So if anyone has any doubt in the question, please ask me. Either or I will go to week 10.
Madam,
Yeah.
can you explain the code, madam, please?
Okay. Where did you have the issue? Did you try solving it?
Oh, can you explain, madam, once?
Did you try solving it?
Yes, madam, I am trying.
Okay. Where? What is the issue? Where did you face the issue?
Line 4, madam.
Line 4.
Yeah, madam.
So A. What will be A? How can we represent it? Tell me. Sequence number, and inside it we will have a value city and gender. This is how our A will be. Okay. This is what they're saying. So sequence number will change to 1. Maybe sorry 0. Suppose this 0th person is from Chennai, then we will write Chennai here, and gender male, and then we will go to other sequence number, suppose 1, and then again we will write suppose Delhi, then male, then this, and so on. Okay, this is how we are representing our A. Clear?
Okay,
This
madam,
is
clear.
clear. Now what they are asking, now we are creating a metric, and we are taking whatever is the, how many keys are there in the A. Why? Because we need to create a matrix of n cross n. So for each I in keys of A, so suppose there were 3 cross 3, we are making the matrix. So the keys of A, which are sequence number, J is also sequence number. If I is not equal to J, which means it is not a diagonal element, and I and J are related, so we will make an edge. Okay, we will put 1 there. What is related here? Is related, we will find out here. X and Y, what will X and Y be? Sequence number, city, or gender?
City and gender.
Yeah, city and gender, this value. Then they are saying if the first of X is equals to first of Y, what is first of X and what is first of Y?
City, ma'am.
Correct. And so they should be, city should be equal, and last of X is not equal to last of Y, which means
Gender is not equal to.
correct. So if they are not related, then there will be an H. If they are related, then there will be an H. And what is the condition to be related? This condition.
Ma'am, gender should be different and city should be equal to same.
Right. Correct. I hope it is clear now. I think you might be able to solve this question also.
Kindly show the options of the previous question.
These are the options.
Thank you, ma'am.
Try this one also. This is also the difference between their marks is between 20 and 30.
Ma'am, options. Ma'am, option 3, ma'am.
Yeah, very good. Was everyone able to solve this question?
Yes.
Is everyone clear in this, or does anyone have any doubt? If anyone is stuck at any line, please tell me. Tanmay, are you talking about to make a matrix, or here the get matrix, this get adjacency matrix?
To get adjacency matrix.
Okay. To get adjacency matrix is this procedure. So we are putting D here. D is the dictionary, okay? This dictionary and the subject. So these are the values. D, and suppose putting physics here. So so what we will do is, first, of course, we will make a create a matrix of n cross n. Then we will go to for I in rows of matrix, and for j in columns of matrix, just like we always do. If I is not equal to j, which means they are not the same. The sequence number is not the student is not the same. Then their difference, the difference between their marks, this is the difference variable. and the difference is between 20 and 30, then we will create a matrix. So what does this line mean? How many should I be greater, j be greater? How much by I should be greater, and what should be the value of j? That is what they are asking. So if I minus j is between 20 and 30, then only we will have an edge. So we will see which option is the most appropriate. Okay.
Ma'am, actually, I have a doubt.
Okay, Sanya. Yeah, please tell me.
Ma'am, there is in line 18, there is a sign of less than equal to in both.
Hmm.
We use less than equal to for at most, na?
So what does this mean? 20. So difference should be greater than equal to 20, right? So what do you think it means? Difference should be greater than. So it is a lower limit or upper limit?
Upper limit.
Upper limit.
Difference should be greater than, not less than. Difference should be, oh, sorry, it got closed. 1 second, I'll open it. Next question. Yeah, so I was saying, is my screen visible?
Yes.
Yes, ma'am.
Greater than equal to 20. So this is 20. It should be greater than. It should be at least. It is lower limit now. Why upper limit? Upper limit is 30. Upper limit is 30. It should be less than 30. Are you getting? Okay. Is there any confusion here?
Ma'am, please explain one more time.
Yeah. So difference, if this is our line, difference is greater than equal to 20. So how we will represent is, suppose this is the line 20 and it should be greater than 20. So the least value it can get is 20. So difference can be at least 20. What is the least value it can get? It can get the least value as 20. So that is why it is at least 20. And what is the upper limit? Upper limit is the upper, where should it stop? At most value, it is 30. At most is 30 and at least is 20. Okay. Hello.
Yes, ma'am. I'm also clarify the difference and the representation of at most and at least.
That is clear here in the question itself. This is for at least 20 and this is for at most 20. Don't
Ma'am, not
remember
in
it. Try to, huh?
not in this question, but in general, kindly explain the representation of at least and at most.
Representation like which sign to denote when?
Yes, ma'am. Like we can differentiate in every question, like this is at most and this is at least.
If x
In
is
that
greater
way.
than, if x should be greater than equal to 10, it means it should be at least 10. Okay. And the opposite is at most. Is it okay?
Yes, ma'am. Now let's go to week 10.
Okay, so here is just the screenshot of train dataset and station dataset. Just look at it once. Okay, it might be helpful that the distance is given, station name is given, and these things are given. Just look at it once. You don't need to remember it. Just you need to keep it in mind. So there were some pseudocodes given that if we want to go from station A to B, how can we go there? First is directly A to B. Now we need to find if we can go from station A to B via train directly, that we don't need to take any stop between. We don't need to change that train. Okay, so that is what we will be trying to do here. So direct route will take a trains data set. So just for the purpose of explaining you, I took this trains data set. Okay, T1 will start at A, it will end at B. T2 will start at B and end at C. T3, these T's are trains, okay? And start is a key and end is also a key. Trains is a dictionary of dictionary where T is also a key and inside T, start is a key. And inside start, there will be a value of station. This is what we are doing here, okay? I hope this is clear. So when we take trains, this trains as parameter, stations we will take empty. Then what we are doing is we are making a station dictionary also, where we are doing something. What we are doing is if what was the value of this? So our trains dictionary was like this. Trains was like T1. Inside it was start at A and end at whatever B, suppose. Okay, it was kind of like this. Now they are saying, I'm asking what will be the value of this. Trains, inside trains we have a T key, so let's take T1, and inside that we have start key also. Okay, but what is the value represented by it? It is A. So inside stations we will have A, so true. Okay, is this one clear? So for each of this, for ending also, for this B also, we are making a key. Here. B also, we will make a key and we will put it as true. So stations, we are just, in stations dictionary, we are just writing all the station which are there in our trains dataset, this trains dataset. Okay. Is it clear till here? Station status, station dictionary and train should be clear, because we will be using it in other pseudocodes also in this whole week. So again, we will make a matrix of n cross n. N is the number of stations, and we will make a station index dictionary also. What we will do in station index dictionary is, for each S in keys of station, keys are this A, B, C. Okay, C is also true like this. This is the station index. What we will do is we will wait a second. I equals to I plus 1 here. So first we will take station index will be A. The key is, first key is A, right? And with first key, what will be the value? I. What was the initial I? Initial I was 0. So value will be 0 like this. So for each station, we are assigning it a number so that it will be easy to denote it in matrix format. Okay, that is what we are doing. Just putting an index to each key. 1 minute. Okay. So, yeah. Everyone is clear about trains? What was trains? T1 with start value, a start as key, and it will have A, then end will have B, and so on. With then T2 also will have start, end, then T3, and so on. Okay. And stations also, I think you all got it. Stations is A, true, B, true, and C also true. Then station index was A, 0, B will become 1 because we are adding I equals to I plus 1. Then C, 2. Okay, like this. Now, till here, is everything clear? If you have any doubt now, you instead of writing in chat, you can just speak. Okay. Then for each T in keys of train, in train dataset, what were the keys? T1, T2, T3, T3 were the keys. So here, I and J we will put. What will be the I? The station. What is this? Trains of T will have a start also, which is this start, right? It have start. And what is the value? A. So A. So station index of A. Station index of A is 0. Okay. So I will be 0. Then J is the station index of this. Why this? Because here we are putting end here. So J will be 1. Because the station index for B is 1 here. That is why. So I is 0 and J is 1. So what we will do is we will put this in direct matrix. We put that I and J have an edge. What we will do is we will make a matrix 1, 0, 0, 1. So where will we put this one? Tell me. This. Here we will put it. Okay. But actually the matrix will be a little bigger because we have 3. We are making a direct matrix. Okay. So we are saying if any train T1, T2, T3 inside it, if any train has a starting and an ending, then we will directly put 1 there. Okay. So this one we are done. Now where will we put 1? The next one will be where? Depends upon our trains data set. Train. I'll write it here. Okay. Just want to erase it. So between A and B, there will be an edge. Don't think about of station index right now. Think like this: A, B, C, A, B, C. Where all should we make an edge? Tell me. A and B here, right? Then BC, B and C here. Then AC, A and C here, right? All other will be 0, 0, 0, 0, 0. Is this clear? Why? Is this clear?
Yes, ma'am.
Yes.
Okay.
Yes, ma'am.
So it was 1, 1, 1, 0, 0, 0, 0, 0. Then again here instead of A we are taking 0, B we are taking 1, C we are taking 2. Again A, B, C. So here also we are doing the same only. We will put 1 here and 1 here, and other places it will be 0 because there is no direct edge. Okay. So is this code clear? This direct routes?
Ma'am, edge and hops are different or the same?
Edge and hops are, see, hop is a different thing. Like hops is like uh, okay, I will explain you later that because I have to make you understand that one hop route also. So I will tell you the code for one hop, two hop, and three hop. Not three hop,
Just
but one
for
hop.
a while, like they both are different terms.
Yeah, they are different. Edge is like this is an edge here. We are not saying that we are hopping between trains. We are saying this is the direct route. Okay, so this is the direct route. That A to B we can go directly. Edge is just a term, a general term for graph. Hopping is different thing.
Okay, ma'am.
So this one is clear how we are making direct. This right. Okay, now we will go to one hop. So previously what we were doing is we were saying that if there is a train goes from A to B directly, that this is a start and this is end. So we will put an edge here. We will put one there. But now we are saying that if a train goes from A station to B station, but not directly, we want that a stop should be there. One stop should be there. There should be one station between them. Okay, suppose Y. We are saying first we will go from A to Y and from Y to B. Okay, this is our one hop that we are stopping in between the station. Okay, so when we see it, just looking at it, will there be an edge from A to Y? A direct edge, indirect.
No, ma'am.
A to Y. Why
Oh,
no?
yes, yes, yes.
Ah, A to Y there will be, but A to B no. Because we are saying from A to Y to we can go directly, and Y to B also we can go directly. There can also be a direct edge here, but not from A to B. Okay. This is our one hop. So how we will code it? In one hop also we will put our direct matrix, which was 0, 1, 1, 1, 0, 0, 0, 0, 0. Okay. For each I in rows of direct, suppose we are taking ABC only. Okay. Instead of taking 0, 1, let's take ABC only. So I is A first, and J's, J will also be A. And again, K also we are taking A. Okay. So they are asking if there is a direct I to K. A to A, are we going A to A? No, we are not going A to A. So we will not go inside it. Okay. Then what will change? K again will change. B. Are we going from uh, A to B? A to B. Yeah. A to B we are going. Are we going from K to J? What is K to J? B to A. Are we going from B to A? No. So we are checking. First, what did we check? A. Let's make a table. Okay. I value, J value, K value. I first we will check with A. J, A. K or A. And right. And what we will check? IK and KJ. A to A, no edge. I to K, which is AA. No edge. Then K value will change. B. Then I to K. A to B. A to B. We will check. A to B, there is an edge. But K to J, what is K to J? BA. BA, no edge. Right? Then K will change to C. A to C. A to C. Is there an edge? A to C. I to K. Are you getting how I am checking? I have just put it in table format. Everyone is getting right how this is why I wrote this part. Hello. Okay. To see, yeah. So next we will check A to A to C. Okay. Then K to J. K to J is A to C. C to A. So no, again no. We because there is no direct edge here, right? These are the direct edges. Now what will change? J will change to B, and K will become again A. Now what we will change? I to K. What is I to K? You tell me. You need to answer. Is everyone getting this part? I to K and K to J. H is why we are checking it. Just this is this A to Y to B. Just the example I gave before. That is what it is. So sorry. Y is K here. Y is K. Okay. So we are saying.
Can you again explain this table, ma'am? It got confused actually.
Okay. So you remember the example I gave A to Y to B?
Yes, ma'am.
So they are checking now I to K to J. Okay. K is
Okay,
Y
understood.
here. We are stopping at K. Okay. So we have this loop, 3 loops here. I, Y, and K. Now, first I's value will remain A. Instead of A, you can use this also 0, 1, 2. That was the station index, whichever you are comfortable with. Which one do you need? I did not use this because you might be confused with this 0 and this 0, 1. Okay, that is why I didn't use this one. These. So first, I's value will be 0, which is A itself. And J value will be A. K value will also be A in the very starting, right?
Yes, ma'am.
Then we will go
Ma'am,
inside it and
I value should be as per the table, as per the matrix, I value should be 0, right?
yeah, that is what I was saying. In station index, A was indexed to 0, B was indexed to 1, C was indexed to 2.
What, 2, yeah.
So instead of taking 0, 1, 2, I just took A, B, C. We can
Okay.
also, okay, do you want me to take 0, 1, 2? We can take that also.
Yes.
Because I's value will be changed with 0, 1, 2 itself. So let's do this 0, 1, 2, okay? Yeah, I value will be 0 in the starting and J's value will be?
J value is 1.
First,
Oh,
no,
first,
first,
everything. Yeah.
everything will be 0, okay?
Yes, ma'am.
Now, what we are checking is I and K. I just wrote here IK and KJ. This one I wrote here. Got it?
Yes, ma'am.
IK, what is 0, 0? Is there an edge between 0, 0?
Yes,
Here,
ma'am.
this first is.
No,
No, it is 0 itself.
0. Yes, ma'am.
Correct. Now, we will check. Now, there is no edge. We will go up and K's value will change. K value will change to 1. We'll check 0 and 1. Is there an edge between 0 and 1? This is 0, 1, 2, and 0, 1, 2. So tell me 0, 1, which means this value. There is an edge, right?
Yes,
There is
ma'am.
an edge between. But KJ, what about KJ? KJ 1, 0. Is there
Yeah.
an edge between here?
Yes, ma'am.
K. There is no edge, so we will change our K's value again to 2. Okay.
Ma'am, how we are
Yeah.
how we are checking that there is an edge or not?
This direct matrix we have. This is the direct matrix. This one. Able to see? Are you able to see my cursor?
No, ma'am.
Okay. Okay. This is the direct matrix,
Okay.
and
Ma'am,
indirect.
wherever there is 1, there is an edge, and wherever there is 0, there is no edge.
Yeah.
Okay.
So depending upon IK and KJ, we are just checking. We are finding where to check. This will be 0, 0, 0, 0, M 0, 0. Will be this one. Then 0, 1 will be this one. M 0, 2 will be this element, right? This is how we're checking. Now, are you able to understand this IK and KJ? We are just putting 0, 1, 1, 0. We are just putting there M of 0, 1. Is there an edge? Is it equal to 1? That is what we are checking. Okay. This part is this itself. See here. Okay. Understood now? So now this was not the edge because 1 is not there, right? 1 is not there. So now, yeah, you were saying something? Hello? Okay, so K will change to 2 now because K is the innermost loop. That is why it is changing there. So what will be IK value? I will be 0 and K will be 2. So what does this mean? IK is this. So you see this line. Let's put it here. Direct of 0, 2 equal to 1. Is it true or false? This condition. Now do you get it? What we are doing while changing IK?
Ma'am, your voice is breaking.
It's sometimes just a problem of Wi-Fi. Yeah, so this one, are you able to understand? This one, 0, 2, we changed K. What we are doing is we are putting the I value, K value, and we are checking if is it equal to 1, which means is there an edge between 0 to 2, right? Now is
Ma'am,
it clear?
KJ will be now 2, 0, right?
Yeah, K is 2 and J is 0. That is right. Now I hope this is clear. How we were this one
In
part.
second row, third column, why you write 2 there?
This
No, ma'am. In JK, sorry, IJK, like in second row, third column.
Which one are you talking? Here or here or here?
Ma'am, the third one, third circle.
This.
Ah, yes, ma'am.
Why are there two
Eighth.
here?
Yes, ma'am.
We are changing our case value. K is a for each loop. This is in for each loop. So first its value will be 1, then its value will be 0, 1 and 2. That is why its value is changing because it is in for each loop.
Ma'am,
Are
when
you
zero,
getting?
when one, when two. Ma'am, like if when zero, if no edge. One, if edge is present, and two when.
No, no, no. These 0, 1, 2 is sequence number. This is not edge. Edge is inside what is written inside it. These are the edges. Here 2 represents C. This is A and this is B and this is C. This is what it represents. A is the values of I, K and J are uh, not these 0, 1 edges. They are
Ma'am,
these
are
station
the
index.
index?
Index. Okay. The value we are checking here is here, this part. Okay.
Ah, yes, ma'am.
I hope you got it.
But ma'am, when we say that we are checking for each I in rows, we take values of the row like 0, 1 and 1, not 0, 1, 2. So we should take 0, 1 and 1 instead of 2.
No. What are the rows here? Rows are actually the index values. These are the index values, not the actual values inside it. Actual values will be represented like this. Okay.
So ma'am, how we are checking that it is uh, direct direct or not?
This is our direct matrix. This one. We computed before this here. Direct route matrix. Okay, suppose this is the direct matrix, which means from A to B we have one train. From A to C we have we have a train. We have a direct route. At A to C we will go to any train T1 or T2 or T3. This is the direct matrix. From here we need checking if there is an edge or not. So this itself is direct matrix. This got it?
Okay, then when there is 0, 2, then why it is 1?
Here it means that from station 0 to 2 we can go by a train T directly. This is what it means here.
Okay.
That is what direct denotes. That from which station to which station we can go directly without changing our train, without stopping it in between the stations. Okay.
Okay.
So now, yeah, we checked this one also. What 0, 2 and 2, 0. Okay. So was there an edge between 0, 2?
No.
2, 0?
No.
Now what we will do? Now it has ended. Now we will change the value of J. Why J? Because the upper loop before K, it was J here. This J. Before K was J. Now again we will do everything again. I will remain 0, J will change to 1 and K will, what will be K?
0.
Again, I, k, we will check the value. I is 0, k is 0. Any edge?
No.
Then kj, what will be the kj value?
0, 1.
Was there any edge here at 0? If there was no edge, so no need to check this because there is an and condition here. Okay. Now k will change to 1, right?
Yes.
So we will check 0, 1. Was there an edge? 0.
Yes.
Here. 0, 1. Here. Yeah, there was. What about 1 and 1? No.
No.
kj? No. So again, we won't put here. Now we will change to 2. What will be our values? 0, 2. Was there an edge between 0 and 2? Yeah.
No.
0, 2.
Yes, ma'am. There is an
It
edge.
was there. And k is 2
How there
and
is
j?
edge between 0 and 2? I think
J
there
is
is
1.
no edge.
What about this? 2 and 1?
No, ma'am.
0.
There is no
Yeah.
edge, ma'am.
Okay.
Ma'am, I didn't understand the last part. How there is an edge between 0 and 2 and not between 2 and 1?
0 and 2. There is this edge. But 2
Oh, okay. Okay.
and 1, there is no edge. Sorry, 2 and 1 here. It is not there.
Okay, got it.
Okay, so you can do it now. Can you do it yourself? Now again, j value will change to 2, 0, 1, 2. Sorry, 0, 1, 2. We will keep on checking. Okay. So when should there be an edge? So we are saying that a train will go from A. What was our train's data set? Just by looking at this train data set, can you tell me that is there any part we can any one hop route? Is there
Ma'am, repeat
anywhere
the
like
question.
any one hop route just by looking at this train data set? Trains. Say.
A to C, ma'am.
A to C by B. So
B.
first we will go to A, B, then B, C, right? A to B, B to C. So this is our one hop route, right? Yeah.
Ma'am, is there more than
No,
one
no,
hop is also there?
no. Which? More than one?
Yeah, because you just a few minutes ago you just explained the hop means that there is a one station
Okay,
between two.
more
So
than one hop.
yes, ma'am.
Yeah, more than one hop, so there can be. I thought more than one route
Okay.
here. Okay. Yeah, one more than one hop, so we can do. We can do it in two hops also. So like that. Again, we will have to do everything. We will have to check again by changing I, J, K, that kind of thing. Okay. So now let's move to. So this one, what we did was we were only taking A to B to C, right? We were only taking one hop. Now we are saying within one hop. What does this mean? That one hop plus the direct routes. One hop, direct routes also, So what will change is we will just put, we will also initialize our one hop matrix with direct matrix. So it will automatically already have the edges which were there in direct matrix. So the edges which were there in direct matrix will already be there in one hop matrix. So that makes sense, okay, right? Direct matrix also we are including, and we are also including the code for one hop. And we are initializing it with direct matrix. Understood? You can do this one your own, right? Two hops also you can do. Is it clear what I just said within one hop?
Ma'am, can you
Previously it
show
was
us
A.
2 hops, ma'am?
1 minute. So previously it was A to Y and Y to B. So we will have an edge between A to B. This was for one hop. But now we are saying we will also have an edge from A to Y and B to Y in the same matrix, which is within one hop. Within one hop. Okay? This is what I'm saying. I hope it is clear. I'll show you two hops also. There isn't any change. Within one hop is clear, just to be sure. So again, what is two hop? We are saying A to Y to B. Now we are saying from B also, from B we can go to C. So this was our one hop. Now we are saying that from B to C also there is a direct edge. So in this we can say that within two hops we can go from A to C. Understood? This is the basic mindset with what we have to keep. That one hop already we have an edge, and there is a direct edge also present. Then we will have an edge in A to C also. Okay, clear? Is it clear? Someone was asking me
So
about two
this,
hops.
okay, so this means 2 hops, ma'am.
Yeah, this is two hops within two hops.
Okay, got it.
So we will add these now. So this you understood now? How?
Yes, ma'am. A to B and then B to C, ma'am. Through via Y.
Yeah. Mhm.
Yeah.
So what I said was there is an edge from A to Y to B, which is one hop. है ना? I to K, they're saying one hop. I
Yes,
to
ma'am.
K, one hop, and a direct edge from B to C. This K to J. This is what they took here now. K to J. This is this, and this is this. Understood?
Yes, ma'am. But ma'am, how this its matrix would be?
How it's metric? Same, just like it was for one hop. We will keep on changing 0, I, J, K, and we will keep on checking if there is an edge between one hop and there is an edge between direct from K to J. Then we will make it here like A, B, C, A, B, C. Suppose these one, it will remain 0 only. So suppose there was, so we are
This,
saying A to C we can go. A to C. Here it will be 1. And also A to B will also be 1. Why? A to B will be 1. Because it
because
was
of
already present in.
one hop, ma'am.
And B to C will also be 1. B to C will also be 1. Why? Because it was there in direct matrix. And direct matrix, so one hop also it will be there in. It will be there in within one hop also, na? B and C, B to C. B to C will be there in within one hop or not? Tell me.
Yes, ma'am.
Okay. Clear now?
Yes, ma'am.
Yeah. So there was also concept of edge labeled graphs. So what we do is now we are just writing there A, B, C, A, B, C, 0, 1, 0, 1. है ना? But now, but what will be more meaningful? If we can write here, that from A to B we can go to through T1, and from A to C we can go through T2. It will be more meaningful, right? Hmm? That is what we want. We want to label our graphs, label the edges of our graph. That is why it is used. So what we are labeling here with is we will go to, this is given in very short format. Okay, all this code is not given here fully. So in continuation with that only, what we will write here is distances. We will write that A to B, by how much distance we will go. Minimum distance, okay? So we are saying that, okay, T1 we will take, which is the first T in keys of train. Then we will take I, station index, 0, whatever. J will be the station index of ending. So what was our train's data set?
Ma'am, N should be 2, right? J should be 2.
N,
J should be 2. I should be if I should be 0, then J should be 2.
why?
Because it says I is equal to start, right? T, and J should be
I,
station 2 index is end at the end.
no. Wait, I will show you. It is according to our train's data set, no? This one. Whatever we were assuming, this one. Start is A, so T1 starts at A and ends at B. So I will be 0 and B will and J will be 1. That is what start and end is there. Start and end is not actually the station. It is where T1 is starting and where T1 is ending. Okay.
Okay, ma'am.
Were you able to understand this?
Yes, ma'am. Understood.
Okay. 1 minute. It starts. So, tell me what is T? T1, because it is keys in train. Then the station index of A will be 0, and station index of B will be 1,
1.
because so if there is a direct edge from I to J, 0 to 1, sorry, if the direct distance, which is this direct distance, it is currently 0, which meant this is a 0, 0, 0, 0, 0, 0. This is not direct matrix, this is direct distance matrix. Okay, so it is currently 0. So what we will put is, instead of putting the 1, we will put its value of the distance of it. Let's not take this one, we will take the distance one. 1 minute. I must have written it somewhere. Let me write here distance also. Let's keep the key as distance also, then only we will be able to work with that. Suppose the distance here was 5. Okay. Not 5. Let's change it. 7, 6. Let's put one more. Here. T4. Start at end at B. Distance is 4. Okay. Suppose this is a trains data. Hmm. Then, yeah. So 0, 1. What is the distance between them? 5. Here also. These are the index I have written 0, 1, 2, 0, 1, 2. Okay. These are the indexes. So 0, 1 we will write here. What we will write? Tell me. This distance, no? We will write 5. Yeah, write 5 here. Okay.
Yes,
Why
ma'am.
you understood? Huh. Then next will be,
Ma'am, between 1 to 2, ma'am, it would be 7.
yeah, we will write here 7. Now what will happen? Now A and B are coming here. So we will go to else block. Why? Because it is not 0 now. Here it is not 0, it is 5.
Yes, ma'am.
So because A and B we already have in here also and here also in B. So we
So,
will go to
we,
else block.
and we will take, ma'am, A and B 4, ma'am, because it is the minimum one.
Yeah, we will change it to 4. So if the edge here is 0, which means we have not started, like it is empty only. This is the first occurrence of the train of this edge, start to end. That this is the first occurrence. Then so we will take the current distance only. Current distance. But if we have already encountered it, we are encountering it
Current
more
distance
than one time.
will be 0, right, ma'am? We start
Current
with
distance, for everything initialization is with 0 only here.
yes, and
So
then
if it is 0,
we change it to 5, then 7, and then 4. Okay.
then yeah. But if we have already encountered it, we will write the minimum of current distance
Excuse
and the
ma'am.
already written distance. Yes.
Ma'am, initialization 0 only in list, not in dictionary, na? As it returns error.
Here I'm talking about creating a matrix with n cross n. It will initialize with 0 itself. Even dictionary we can initialize empty. What is your question?
Ma'am, we can initialize dictionary with 0 or empty.
Both. Both.
Dictionary is nothing but a key value pair. So
Okay.
you can
Yeah. So where were we? Yeah. We were saying, yeah, here. So if we have already encountered the distance, we have already encountered ij. That means like here it was already 5. It wasn't 0. Then what we will do is we will in the current distance, which was direct distance here was 4. 4 and the already given distance was 5. We will put the minimum value between them. Okay.
yes, ma'am.
Do you get it?
Yes, ma'am.
Okay. Okay. So I hope this is clear.
Okay, minimum distance will be 4, and train T distance will be 5. Yes, ma'am.
So this is one of the usage of this. Here what we are doing is we were making this dictionary. What is one hop distance? Okay, in one hop distance So we are using it here like this. This is just a usage I gave for an example, as an example. So we will take the distance between whichever is the new distance, whichever the new distance, which is the one we have just encountered. This is the new distance we have just encountered, or the already present distance. We will take the minimum between them. Okay. You can read it once, the code. Try reading it, okay, right now, and let me know if it's clear. Okay. I'll give you 5 minutes. Are you reading the code?
Yes, ma'am.
Okay. Do let me know if when to move on. Is it clear? Hello. Okay, so let's go. Um, okay, so next is week 11. Let's do some question before it.
Ma'am, can you explain line
Yeah.
number this code, ma'am?
Um. Okay, so one hop distance we have done create matrix of n cross n. Okay, this is the we know already, and this is we have initialized. Okay, I hope whenever you need to stop me, just let me know. Okay, and k also we know why we are looping through k. Then if there is a direct distance, which means if direct distance is greater than 0, so what is this condition? This condition previously it was like this now, is equals to 0, m of I j is equals to 0. Then so we will take the current value only. Else what we were doing is we were taking the minimum value. Here is if we are saying that it is greater than 0, that we have already encountered it. Okay, right?
Yes, ma'am.
This is for else, and one was here.
Ma'am, else part I have understood. The part which the new distance is equal to that part I
Why?
didn't.
Okay, new distance we are making it because this is we were doing a one hop distance. We were going from in this we are going from I to k and then k to j. है ना? So what will be the new distance now. The direct distance of this plus the direct distance of this. You got the new distance? Why?
Yes, ma'am. Because I got confused because if you see the if conditions, ma'am, it says that it has to be more than 0, right? So that means at least it should be here. It should be 1. So if
It,
one,
more than 0 means that we have already encountered it. That it is the second. See, we were changing from 0. We were changing to 5. The previous example. Remember, we were changing to 5.
yes,
The condition when we were changing to 5 is that it is the very first time we have encountered this, which is this else block. But then second time we were changing it to 4. Now this 4, when we are changing, this was this condition, that it is greater than equal to 0, not 0 now, that we have already encountered it. This
oh,
is
okay,
why we are using greater than equal to 0. Got it?
got it, ma'am.
So let's go. Okay, question also you should do first. The following. Okay, I will just a minute. Okay. 15th. Let's just go to recursion. We will do the questions afterwards. So recursion, what is recursion? When we are calling a procedure again in that same procedure, that is recursion. Calling itself using the same procedure in that same procedure. That is what calling itself means, basically. So in this, I've used sorted list insert. Okay, how we are inserting it. This is insertion sort. Not insertion sort, recursion. I hope you know that factorial one. Factorial one is clear. For n factorial, what we can do is, if you need to factorial of 3, then what we will do? We will do 3 into the factorial of 2.
2 in
And then to find the
n minus 1.
Factorial of this, and this will be 1. So this is how what we will get is 3 into 2 into 1. So here is it's calling itself factorial of n minus 1. Okay, I hope that you know the basic example, that one, right?
Yes, ma'am.
That is clear. So now do the insertion sort, how we are inserting. Then okay. So suppose our L is okay. Suppose this is our L. L original. Let's say it. The L original is the one we are putting it here. L original we are putting. Okay. Is the screen visible? This is our L original. Okay. Now we need to insert sort it. So this is insertion sort. We will put L original here. Sorted list is empty. Empty. For each Z in L. What is the first Z? Value of Z is 90. This is the first Z, right? Sorted list insert.
Ma'am,
90.
your voice is breaking, ma'am.
Wait a minute. I will connect again then. Hello. Is it better now?
Yes, ma'am.
Okay. Yeah. So this is the L original, and sorted list is empty. Now taking Z, which will be 90. Okay. So what we will put L here, this L. L is a parameter, okay, not this full L. What will go inside this? Tell me. What will be the parameters inside it? Empty list and Z is 90. This now. This is just calling this one, this procedure. Okay. I hope that is clear. Is it clear?
Yes, ma'am.
Now what we will do? New list is empty, inserted is false for each Z in L. So Z was 90. Empty and 90. What we will do? We will skip this block, right? Because there is no Z in L. L is empty. Okay. We will skip this and we will go here. If not inserted, tell me this is true or false right now?
It's false.
This one. Should we go inside this?
Yes, ma'am.
We will go inside it and new list will become
90.
90. So we will return 90. So this will sorted list will become 90.
90.
Now what we will do? For each Z in L. Now again at Z here will change. This
Yes,
Z
ma'am.
will change to
90.
7.
Oh, now it's 70, ma'am.
Because 90 we are done with. Now 70. Now, so what we will call here? Our list will be 90. Sorted list is 90 and Z is 70.
70.
Now this is what we will. Our L and X will become here. L will be 90 and X will be 70.
70.
This one will go. Now, okay. Now we will go inside this block. For each Z in L. Now Z is
70.
70. If not inserted, true, because inserted is false. Then if X is less than Z,
Yes.
X is, what was X? Sorry, Z. Here Z is 90 now.
Yes, ma'am. 90.
X is 70 is less than 90.
Yes, ma'am.
Then new list will be appended. So new list will become
70.
70. Now we will go down and we will inserted will become true and we will append Z also here. What will new list become now? 70 and 90, right?
Yes, ma'am.
This, now what about this condition if not inserted?
Which one? The
Yeah, this.
if condition, it will be
False now because inserted has become true. So we will return our new list. And what will be our new list?
70.
90. Yeah, right. Now sorted list will store 70, 90. Is this clear for everyone till now?
Yes, ma'am.
Okay. Anyone has any doubt, please ask right now. Okay. Then 90, 70. Then our Z will change to
80.
Now what will be our sorted list?
It's 70, 80, 90.
70. No, right now it is
Oh,
70 and 90
70 and
only.
90 only. Yes, ma'am.
And our X will be here. What is X?
70, 90. Oh, X here. I mean, procedure sorted list insert.
Mm-hmm. This
Yeah.
here.
Yes, 70, 90.
X will
Oh,
be
X will be 80.
80, right? 70, 90 will be our L and X will be 80. Why? It came from here.
Yes,
Z.
ma'am.
Z was 80 now. Now again we will go through this for each Z in L. Z is 70 and 70. Okay. First 70. If it is not inserted. If X is less than Z. Okay, I'll clear it first. Z is 70. X is 80. It is less than Z. Not
No.
true. Then we will where will we go?
Go to if.
We will go here. We will append our Z,
Yes, ma'am.
which is what is that? What is Z?
80,
Z,
right?
Z.
Sorry, Z is 70.
70, right. We have appended 70 now. Now we will go up again. Now Z is 90. Now we will check here again. X is less than Z.
Yes,
What is
ma'am.
X? X is right now 80 only. X
80.
is 80 only, but Z has changed to 90. So now this is true. Then what we will do? We will append X.
X.
Now X will become
True.
70 and 80. Sorry, new list will become 70, 80 because
Yep.
70 was already here. Now 80 we have also appended.
Hmm.
Then insert it true. Okay. Then again we will go up. We will go up.
Hmm.
No, we won't go up because there is no. We will go up, but we will check if there is any Z. No Z. So we will go down. If not, okay. We have to insert Z also now. We have inserted X. Done. 80 has been inserted, right? Then inserted became true. Okay. Then we go down here. Then again, what we will do? We will append Z, which is 90, right?
Yes, ma'am.
So 70, 80, 90. We got it. We got it.
A new list will be 70, 80, 90.
Done. Okay. Is this procedure clear?
Yes, ma'am.
Okay. We can do this using recursion also. How? So how we were doing here is we were doing 90. Yeah, 90 and empty list. We were doing it on this. Then we were making it Z was being 70, 80, and slowly we were putting our values here, right? And then at last we got it. Now what we will do here is if length, this is the base case, this is the recursion one. Okay, this is the base case. If length is less than equal to 1, which means there is only one element present or the list is empty, then to we will directly return L. But else what we will return is we will put two parameters here. So sorted list, one to is insertion sort rest and one is first. These are two parameters. So here we were putting sorted list and Z. Here which are the parameters? Insertion sort of rest of L and first of L. Okay. So how we will do here? So if we are taking this 90, 70, 80. First of L is
90.
Insertion sort IS. Insertion sort of rest of L. What is rest of L? 70.
70, 80.
And the other part is 90. So this we are putting in sorted list insert. Sorted list insert. This procedure is the same. Okay. It will take two parameters, one list and one element. Okay. Then
Yes, ma'am.
what will this give? Inserted list, inserted sort of 70 and 80. What will this give? Now our L is 70, 80. This will give sorted list insert of insertion sort of 70. No, sorry, 80, comma 70. This. Are you getting how?
Yes, ma'am.
Because this part is giving us this. 80 will come first. What is the first of L? 70 will come here, and this
And
will be the rest of L.
rest of your list.
List which is 80. Now this, what will this give us? Insertion sort of 80.
Yes, ma'am.
It will give us 80 itself.
80.
Because this is the base case. We will return L. Okay. So this is how our recursion call will go. Clear?
Yes, ma'am.
Okay. So next is DFS and BFS. Okay. So for DFS, this is the code. Let's first see this one. Okay, wait. I'll show the screen also. Yeah, I hope this is visible. So for BFS, what we do is, so the recursion is clear, right? For everyone?
Yes, ma'am.
No. We will start from 0 in BFS. From 0, we will explore all the neighbors. 1, 2, 3. So here we will write 1, 2, 3. Okay. Yeah, we are just writing it. Now 0 is completed because we have written all its neighbors. Okay. 0 is completed. Now we will go to 1. Now for 1, we will write all its neighbors, 4 and 5. Here we will write 4. Here we will write 5. So now 1 is completed. Now we will go to 2. Now for 2, we will write all its neighbors, which is 6.
6.
2 is completed. Now
3.
we will write all its neighbor,
7.
which is 7.
Yes.
Now 3 is completed. 4 doesn't have any neighbor. 5 doesn't have any neighbor. And 6 doesn't have any neighbor. 7 doesn't have any neighbor. So this is our BFS. Okay. Clear?
Yes, ma'am.
So what about DFS now? Okay, clear it. Okay, so
Undirected.
for DFS, we will not explore 0, all the neighbors of 0 fully. We will keep on jumping. So 0. 0.
0 to 1.
Hmm.
1 to 4. 4 to 1.
4 to 1, yes. Then 1.
1 to 0.
1 to 0, 1 to 5.
1 to 5. Yeah. Sorry. 1 to 5. And then 5 to 1.
Again 5 to 1.
And then again 1 to 0.
1 to 0. And from 0 to?
0 to 2,
2 to 6,
2 to 6, 6 to 2,
hmm,
and 2 to 0.
2 to 0. And 0 to
0 to 3,
hmm,
3 to 7,
3 to 7, yes.
7 to 3,
Hmm,
and 3 to 0.
correct. 0. Right. Okay. So everyone is clear about how we use this? How we're doing this? Anyone has any doubt? Okay. Okay. So this one. Okay. This is again the same procedure only. So how we were doing is we were putting 0 here. Then visited of 0 was becoming true. So there have to be two criteria. First is there has to be an edge, and second is that the neighbor should not be visited. So from 0 to we were going to 1. 0 was I now. It was I. Then its neighbor was 1. Okay. And visited also. And visited, we were making 0 as true. Because we have already visited it. Okay. Then we were going to 1. And 1 we had a graph and it was not a key in visited dictionary. So we will go down. And now what we will do is recursion call. But now instead of I, we are taking j. So from 0, we will directly put 1. Now from 1, where to go? There was 4 there, right? 4 in the graph only.
Yes, ma'am.
This
No,
graph.
ma'am. DFS, it's not 4, it's 2. So, oh, yes, DFS, it's 4. Yes. Correct.
Then from 4, we will again, what we will do is visited of first 1 also we made true. And now 4 also we will make true. And we will just keep on doing this. Okay. This is the recursion call. You don't, yeah, this is how we were doing recursion in DFS. So let's look at some questions now. Okay. This is all I wanted to discuss. Yeah, so you can see this example also. Here, we started at node 0. 0 we checked at, it has a edge with 1. So we visited 1. Here we came. This side we came, okay? Because it had an edge with 1 here. So j changed to 1, right? When j changed to 1, we are seeing that 1 does not have any edge.
Yes, ma'am. No more.
No more edge. So we will backtrack to 0. And we will see that 0 we are done with, 1 we are done with. Now 2. We will go to 2. 2 it has an edge. Now we visited 2 and we are done with it. Okay.
Yes, ma'am.
So the questions, okay. 18. I chose the questions from PYQ, which were from week 9 to 12. Okay, those are the questions I chose. That is why I'm not fully completing it. So, 19th question. Okay, so this is the question. Okay, just read it once. This is the extra things given. Book has already been completed. For example, books 0 is equal to 0, 1, 2, 3. This is the serial number 0 and these are the author list. Okay.
Yes, ma'am.
Now this is the question. I think it was in. It was also in GA this time. Grade assignment or practice assignment. Any of these. Do this question once.
Ma'am, can you show us the option? Ma'am, option 4. Oh shit. Not equals to. Shit. Got it, ma'am. Ma'am, are you speaking, ma'am? Your mic is mute, ma'am.
Oh, sorry. I was speaking. I was saying that there is no. We need to check J is not equal to K, na?
Yes, ma'am. I forgot, ma'am, because they are the different author, ma'am. So
Yeah.
I mean, not equals to shows a different author.
Mhm.
So we have to take the different author, but they have co-authored the book. So option 2 is correct.
Yeah. Like this. 0. What? 0th book was co-authored with 1 and 2. Yeah, that is. Uh, with the number of books they have co-authored. Okay. Because that is why we are adding 1.
They have co-authored, but they have different different author. So option 2 is correct.
Mm-hmm.
But I did mistake, ma'am.
Wait, I'll see more questions also. Maybe on DFS and BFS first. Mm-hmm. Okay, fine. This one also too.
Ma'am, can you show us the option? Ma'am, option 4.
Yeah, option 4 is not correct. Who have co-authored at least 2 books with either J or K. Why did you think at least
Ma'am,
2 books?
because if we see the line number 11, ma'am, it says that like J is not equals to K, and
Hmm.
J is not equals to H,
Hmm.
and K is not equals to H, and they are not a member of matrix 2. So matrix 2, if you see, then
It is like this.
so
J,
matrix.
J and K, just take it as authors only. Okay, author 1, author 2. Okay, so we will write here H. H itself is author 3. Okay, if there was one more author, author 4, we can write it here. So there is no criteria of checking if they have authored how many books they have authored. So that is why. Are you getting
No,
this? JK JH is not equal to means that they are not the same author. That we are not writing A1 here itself, A2 here itself. Then it will be repeating. J and K are A1 and A2, and H we are taking author 3.
yes, ma'am.
So that is why we are saying just don't take author 1 and author 2 also. It has to be different authors, not the same. That is why. Yeah, we were. What was your approach?
Ma'am, same what you are saying, ma'am, just now.
Yeah, that author 1 and author 2 are two authors, right? So it should not be that we have written here author 1 itself or author 2 itself. We cannot write it. That is why they are saying that they have to be just different authors.
Okay, got it, ma'am.
Okay.
Yes, ma'am.
So any other doubt? Any doubt? Anyone can ask. If no one has any doubt, then I can I end the session? Chetan, are you there?
Hello.
Hi, Chetan. So
Yeah.
can I end the session?
Yeah. Perfect. Perfect.
Okay.
So, um, guys, if you have any questions, please let us know. If anyone has any questions, if not, we'll wrap up the session now. And thank you so much, Sagan, for this wonderful session and for helping everyone cover the last 4 weeks. Um, so thank you so much for your time, and thank you everyone else for joining today. Just a small piece of information. This was one of our first sessions for this end term revision marathon that we're having by Kaziranga House. We'll be having more such sessions. Sagan and her friends very graciously helped us out with these sessions. Thank you so much, Sagan, for today. And guys, please join the future sessions as well. We have maths 1 session plan, maths 2 session plan, stats 2 session plan, other sessions for foundation level courses and diploma level courses planned. We'll soon be sharing the details for all those sessions over email. So keep an eye out for those sessions as well. And thank you so much for joining today. Have a really good night and all the best for your
So,
end term exam. Yeah, Biswajit.
so before winding up, sir, I have a question from ma'am. Ma'am, why the option one is correct, ma'am?
Yeah. List of
I'm feeling a little bit still a little bit
it's okay.
confused.
It's okay. Yeah. Okay. So list of authors who have co-authored at least this one you got it. Why at least is not coming here?
Yes, ma'am.
So see these two options. If you think aren't they written that it has to be both ways. It has to be J also and K also. They're not saying only with J or K. When you try to eliminate, what do we get? So at least 2 books is not there. At least 2 books is not there. But they have must have co-authored with J or K, not J or K. J and K, not either of them. Both of them. Then only we can write here now. Suppose author 1, author 2. Which author will we write here? Author 3 will only be written here when they have co-authored with author 1 also and author 2 also. No? How? J and K is empty matrix. This. Yeah. So what was I? Wait. What was I was sequence number with author 1, author 2, author 3. So J we are taking as author 1, K we are taking as author 2, and H we are taking as author 3. Sequence number is just book number 1, 0, 1, 2, whatever. Huh? So here when we look at I, 1 minute, I will take the screenshot and I'm showing, okay?
Hello.
Yeah, tell me which was the what was the books? How was it? It had a sequence number book with a list of anyone, the authors, author 1, author 2, author 3. Okay, there was this numbers only itself here, but let's just say author 1, author 2, author 3. Now I is 0, J is author 1, K is author 2, and H is
It
author
is author
3.
3. Yes, ma'am.
Yeah. Then how we are making matrix? Author 1 is coming here as row, author 2 is coming here as row, and author 3 is coming here. So JH will only be there when it is already present in the list of this, in this value, right?
Mm.
That is why. There was one question, I think, in graded.
Oh, okay, ma'am.
I-
Actually, last line, I didn't notice it properly. That last line clears my doubt. That means not member of matrix 2J, K, and I mean these are under indexes, and H is that means
Which
open
means,
index.
yeah,
Oh,
H.
yeah, that means they are the I mean co-authored.
It means that A3 is already not present here.
Yeah,
That
at
we
least.
cannot repeat here A3.
Yes, ma'am.
Wait, let me see. I think there was this graded question also here. I'm not sure if there was in graded assignment 11, I think.
Ma'am, can you share this PDF if possible?
Yeah. I'll have to. No, I don't think it is there. Mhm. No.
No
Because
issues, ma'am.
I
I
got.
understood.
Yeah, okay. Okay, so I can.
Can you share this
Yeah, I'll share this.
PDF chat box, ma'am?
1 minute.
Was that clear?
Yeah,
Yes,
I
sir.
think it was clear.
Okay, perfect. Okay, Sagan has shared the document in the chat, so you guys can take a look at that. You can mail it. Just a second. Let me put the ID there. Yeah, so I have mentioned 3 email IDs in the chat. For the students who are not from Kaziranga House and are joining the session, you can mail us at these email IDs and request for the slides for the session. The rest, the session is available on YouTube. So if you have maybe missed part of it, you can join the, you can watch the session on YouTube. It will be available on YouTube also. So this session was from week 9 to week 12. Earlier we had a session from week 1 to 8 as well, which was conducted by Shubhradeep, who's a current term CTTA, co-TA of Sagan. So you can watch that video first, and then you can watch this video, and I think that should be enough for you to perform well in your end term examination. Though we do not recommend um, this method of preparation, we do recommend you to first go through the lectures and then join these representations. But if in case you have not been able to follow up on the lectures, you can go through these two videos. Both Sagan and Shubhadeep have done wonderful jobs, so I think that should be enough for you guys to prepare for your computational thinking course in term examination. Also, we have more sessions lined up, as I've already mentioned previously. You can join those sessions as well. Soon we'll roll out a email, or we'll send out an email to all of you guys. So keep an eye on out for that. So thank you guys. Thank you for joining today. I'll just wrap up the session now. I'll just stop the recording and streaming.
Thank you,
So
sir.
thank you.
Good
Thank you so much for joining, everyone, and
Thank
thank you,
you, ma'am.
Chetan, for having me.
Thank you,
My
ma'am. Good night.
pleasure.
Bye,
It was
everyone.
our pleasure to host you.
Thank you.
Thank you so much for taking the session, Sagan.